Hello everyone. Today we will see some practice questions from the chapter solution, and this is our part 3. So let's start. Disclaimer slide which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. In next slide, so we will going to see today some practice questions from question number 21 to question number 30. So let's start with the question number 21. 12 gram of a non-volatile solute dissolved in 108 gram of water produces the relative lowering of vapor pressure of 0.1. The molecular mass of the solute in gram per mole is. So we have given the solute mass here, which is non-volatile in nature, and the mass of solvent, which is 108 gram, and our solvent is water, and the lowering of pressure, vapor pressure value is 0.1. So we have to find out the solute molecular mass, which is a non-volatile solute. So options are 80, 60, 20 or 40. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C, which is 20. So the relationship between molar mass of solute and relative lowering in vapor pressure is given by this equation. That is, del P is P naught minus P upon P naught equals to the ratio of moles of solute and solvent. And on simplifying this ratio, we get W1 upon M multiplied by M upon W2. So these are basically, this is basically molar mass of the solute. This is given mass of solute. This is molar mass of solvent. This is given mass of solvent. And we have our solute. We have our solute as 12 gram and the mass of a solvent as 108 gram, and the mass, or you can say that the molecular mass which we have to find out for the solute, we don't know. And the molecular mass for the solvent is 18 gram because the solvent is water, and del P is given as 0.1. So on putting all these given equations in this equation, we have del P equals to or 0.1 equals to 12 divided by M multiplied by 18 divided by 108. And on solving this equation and interchanging the terms from the left hand side to right hand side and vice versa, the M or the molecular mass of the solute is coming out as 20 in gram per mole. So the option C is the correct answer. Okay. Let's move to question number 22. The Henry's law constant for the solubility of nitrogen gas in water at 298 Kelvin is 1 into 10 to the power 5 atmosphere. So we have given Henry's law constant. The mole fraction of N2 in air is 0.8. The number of moles of N2 from air dissolved in 10 moles of water at 298 Kelvin and 5 atmosphere pressure is. So we have to find out the number of moles of nitrogen from air which dissolved in 10 moles of water and 5 atmosphere at 5 atmosphere pressure. So options are 4 into 10 to the power minus 4, 4 into 10 to the power minus 5, 5 into 10 to the power minus 4, or 4 into 10 to the power minus 6. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A. That is 4 into 10 to the power minus 4. So let's see how. So according to Henry's law, we know that pressure is equals to the Henry's law constant for the solubility, multiply by the mole fraction. So here X is mole fraction, and number of moles of N2 is equals to number of moles of H2 multiplied by the pressure of N2 divided by the KH. We just interchange the terms in this equation and add some more terms, and it is given as that pressure of nitrogen is the mole fraction of nitrogen into the P, right? This is the equation we know. And so from here, the pressure of nitrogen is coming out as the mole fraction is given as 0.8 in air and multiplied by the 5 atmosphere pressure. So it is coming out as the 4 atmosphere. So pressure of nitrogen is coming out as 4 atmosphere. And we have to use this pressure in this equation. So we have moles of nitrogen, which we have to find out. So moles of nitrogen is equals to the moles of H2, which is 10 given in the question. So 10 multiplied by P pressure of N2, that is 4 atmosphere. We just have calculated from this equation. So 4 divided by the KH value. KH is 1 into 10 to the power 5 atmosphere. So on solving this fraction, we have moles of nitrogen as 4 into 10 to the power minus 4 moles. Hence, option A is the correct answer. Okay. Let's move to question number 23rd. For the dilute solution containing 2.5 gram of non-volatile, non-electrolyte solute in 100 gram of water, the elevation in boiling point at 1 atmosphere pressure is 2 degrees Celsius. Assuming concentration of solute is much lower than the concentration of solvent, the vapor pressure of solution is. And we have given the Kb here, which is 0.76 Kelvin kg per mole. Okay, so we have to find out the vapor pressure of the solution. So options are 724, 740, 736, or 718. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A, that is 724. Let's see how. So the elevation in boiling point is given by this equation, del TB equals to Kb dot m, where m is molality and it is given by a number of moles multiplied by 1000 upon the weight of solvent. And weight of solvent in kg, that's why we divide it by 1000, or it goes in the multiply term in the numerator. So del TB we have given as 2 degrees Celsius. So 2 equals to Kb value, which is 0.76 multiplied by the mole, which is we don't know until now because it is not given in the question. Multiply by 1000 divided by the given weight of the solvent, which is given as 100 gram. So from this equation, we have N2 equals to 5 by 19. Now from the Raoult's law of lowering of vapor pressure, we know this equation, that is del P upon P naught equals to the mole fraction, right? And on solving this mole fraction or writing this mole fraction equation, we have N2 divided by N1 plus N2, right? And we have given in the question that assume the concentration of solute is much lower than the concentration of solvent. So N1 is very, very greater than N2 because N2 is much lower than the N1. It is given in the question. So we just, delete the N2 terms from the denominator. So this fraction will become N2 divided by N1. And on putting the values given in the question, del P will be equal to P naught, and P naught is given as 1 atmosphere, and we are calculating in mm of Hg. So it will be 760 and multiply by the 5 into 5 by 19 N2 value, right? And multiply by the N1 value, which is 100 by 18. So it will reverse. And on solving this, it is coming out as 36 mm of Hg. Now del P is P naught minus P. So P is coming out as 760 minus this 36. So 36 equals to 724 mm of Hg, right? So the pressure or the vapor pressure of the solution is coming out as 724 mm of Hg. Hence option A is the correct answer. Okay, let's move to next question. Question number 24. An aqueous solution freezes at minus 0.186 degrees Celsius. The Kf for the solution is 1.86 Kelvin kilogram per mole and Kb is given as 0.512 Kelvin kilogram per mole. So what is the elevation and boiling point? Del Tb we have to find out, right? So options are given as 0.186 degrees Celsius, 0.512 degrees Celsius, 0.86 degrees Celsius or 0.0512 degrees Celsius. So you have 10 seconds to solve this question. After that, we will see that what will be the answer. Okay. So the correct answer is option D. So the we know that the del TF or the elevation and freezing depression and freezing point is equals to TF naught minus TF, and the freezing point of the liquid if we take in Celsius degree, it will be in the Celsius unit it will be 0 degrees Celsius minus, and we have given the TF here, which is the temperature of freezing, which is minus 0.186. So TF naught minus TF is minus of 0.186. So minus of 0.186. Minus will become plus, and 0 plus this will be 0.186 already. And del TF is also explained or given as KF into M, and KF we have given as 1.86 and del TF is 0.186. We have calculated here, and M or molality we don't know, so M is taken as M, and M is actually 0.1. And so if we find out the del TB, right? So from this equation we count the M, and M is coming out as 0.1. Now we have to find out the elevation and boiling point. So del TB equals to KB into M. So KB value we know and M value we know. So on putting the values, we have del TB equals to 0.0512 degree Celsius. Hence option D will be the correct answer. Okay. Let's move to next question, question number 25. When mercuric iodide is added to the aqueous solution of potassium iodide, we have to find out which option is correct. Which option will follow this line or this equation. So freezing point is raised, freezing point is lowered, freezing point does not change, boiling point does not change. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A, that is freezing point is raised. Let's see how. So this is the reaction when mercuric iodide is added to the aqueous solution of potassium iodide. So 2Ki plus HgI2 will give you K2HgI4. This is a complex which will form, and as a result of this reaction, the number of ions decreases. As you can see that here it gave the 2 ions, and here it gave the 2 ions. So, and on combining it become a complex, and on dissolving this complex or on dissociating, this complex will give only 2 from here and 1 from here, 3 ions, right? So number of ions is decreasing. As we know, solution with higher number of ions show higher lowering in freezing point. So for this reaction, as the number of ions decreasing, the lowering in freezing point is also decreasing or is also less. Or we can say that lowering in freezing point is less, that means freezing point is raising, or freezing point is raised. Yes. So option A is the correct statement, is the correct answer. Okay, let's move to question number 26. The molecular weight of benzoic acid in benzene is determined by depression and freezing point method corresponds to. So options are ionization of benzoic acid, dimerization of benzoic acid, trimerization of benzoic acid, or solvation of benzoic acid. So you have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, so the correct answer is option B, which is dimerization of benzoic acid. So let's see how. The molecular weight of benzoic acid in benzene is determined by the depression in freezing point method, and it comes out to be 244. But the actual molecular mass is 122. Therefore, it corresponds to the dimers which are formed by hydrogen bonding. And benzoic acid undergoes dimerization in benzene. Hence, option B, according to this concept, option B is the correct answer for this question. Right? Let's move to next question, question number 27. The depression and freezing point of 0.01 molar aqueous solution of urea, sodium chloride, and sodium sulfate is in the ratio of. So we have to find out the ratio of these three solutions of their depression and freezing point, and their concentration is given as 0.01 molar. Options are 1:1:1, 1:2:3, 1:2:4, or 2:2:3. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B, that is 1:2:3. So let's see. So we have del TF for urea. Depression freezing point for urea is I into Kf into M, where I is Hoff factor, right? And so for the urea, the I value is 1, right? Kf will be Kf, M will be M. And for the del TF, for NaCl solution, we have I value as 2 because for sodium chloride, the Hoff factor is 2 into Kf into M. M we have taken same for the urea, NaCl and N2SO4. I is changing. For urea it is 1, for NaCl it is 2, and for N2SO4 it is 3. M is same because the aqueous solution of these two solutions or these two compounds have same concentration, that is 0.01 molar. So we have to find out the ratio. So we put all of them in the ratio. So urea Kf into 1, ratio Kf into 2, ratio Kf into 3. Urea is to NaCl is to N2SO4. In this manner, we have to find out the ratio. So we don't know about the Kf, or Kf will be same because we have the same concentration. So the ratio is coming out as 1:2:3. Hence, depression and freezing point will be in the ratio 1:2:3. And hence, option B will be the correct answer. Right? Let's move to next question, question number 28. During depression and freezing point of a solution, the following are in equilibrium. So we have to remember the concept of depression and freezing point of a solution, and then we have to find out which pairs are in equilibrium from the options. So options are liquid solvent, solid solvent, liquid solvent, solid solute, liquid solute, solid solute, liquid solute, or solid solvent. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A, that is liquid solvent and solid solvent are in equilibrium? So let's see. So when freezing starts, liquid solvent is in equilibrium with the solid solvent. Both have same vapor pressure, and thus at freezing point, the solvent in the liquid state will be in equilibrium with the solvent in the solid state. Because at freezing point, just the freezing is starting, right? So the both are in solvent. If they are in same state, so they are in same state, right? Whatever the state will be, the liquid it will be in the solid. So they are in equilibrium state at the freezing point. So during depression of freezing point of a solution, when the freezing starts, the liquid solvent and the solid solvent is in equilibrium. Okay. Hence, option A is the correct answer. Let's move to next question. Question number 29. How many grams of methyl alcohol should be added to 10-liter tank of water to prevent its freezing at 268 Kelvin? Kf for the water is given as 1.86 Kelvin kg per mole. Options are 880.07 gram, 899.04 gram, 886.02 gram, or 868.06 gram. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. Option C, that is 886.02. So the normal freezing point of water we know in Kelvin is 273.15 Kelvin. And in order to prevent freezing at 268 Kelvin, let the amount of methanol be X gram. We suppose it as X gram. And at the temperature we are preventing the freezing is 268, which is less than 273.15. That is freezing point of water. Therefore, molality M is equals to the X, that is the amount of methanol we have just assumed, upon 32 multiplied by 10. 32 is the methyl alcohol molar mass and 10 is the volume which is given in liter in the question. Reason, and it is coming out as X upon 320. Reason is, since molar mass of CH3COH is 32 gram per mole, that's why we taken it here as 32. And mass of H2 will become equal to the volume of H2 because density of water is equivalent to 1 gram per liter, right? So the mass will become equal to the volume. We know the density will be 1. So that's why we have taken here the volume as at the place of mass, and the molality is coming out as X upon 320. So lowering in freezing point is calculated as Kf multiplied by the molality. And the lowering in freezing point we know is that standard temperature for the freezing point of water is freezing point of water is 273.15 minus we want freezing at 268 Kelvin, so it will be minus 268 and it will be equal to Kf. Kf is 1.86. So 1.86 multiplied by molality. Molality is X upon 320. So it is coming out as 5.15 and is equals to 1.86 X upon 320. On interchanging the terms, we have X value is equals to 886.02 gram. Hence, option C is the correct answer. Okay, let's move to question number 30. Kf for water is 1.86 Kelvin kg per mole. If your automobile radiator holds 1 kg of water, how many grams of ethylene glycol C2H6O2 you must add to get the freezing point of the solution lower to minus 2.8 degrees Celsius? So we have to find out the gram or the mass of the ethylene glycol which we need to add which we need to get the freezing point of solution lower to minus 2.8 degrees Celsius. So if we want the freezing point is 2.8 degrees Celsius, how much grams of ethylene glycol we need. That's what we have to find. So options are 72 gram, 93 gram, 39 gram, or 27 gram. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. So the coolant is given as glycol C2H6O2, which is a known electrolyte. So del TF is given as 2.8 degrees Celsius, which we want. And we know that del TF is equals to 1000 multiplied by KF into molality. So molality is W1 upon M1 into W2. And for W2, we have, we have to divide W2 by 1000. So we take it in the multiplication. And on putting the terms, on putting the values, by remembering or by taking in mind the units of the terms already, because we have taken here the W2 as 1 kg of water, and we have to multiply it by 1000, and because we have already converted it in kilograms, so 1 kilogram, 1000 gram. So the W1 from this equation, on solving this equation, we just have to put the values here in this equation which is given in the question, and we just have to take in mind the units properly. We have to just manage the units here, and on solving this equation, we have W1, or the mass of ethylene glycol which we need, is given as 93.33 gram, which is equivalent to, we can say, 93 gram, right? Hence option B will be the correct answer for this question. Okay. Thank you.